Hi everyone. In this video, we will discuss about the second exam review. The topic still the same. It's about trigonometry, differentiation and integration of trigonometry functions and integration by parts. Yeah, let us start. Number one. The parametric equation of a curve are x equals to 2t minus tangent t, y equals to ln sine 2t. Show that dy dx equals to cotangent t. So if you remember, how do we find the dy dx? dy dx is equals to dy dt over dx dt. So we need to find the dy dt and dx dt from the given function. We try to find the dx dt first. So 2t is become 2 and tangent become secant square t. The dy dt is equals to derivative of ln is 1 over sine 2t, and the derivative of sine 2t is 2 cos 2t. So we can put into the formula. It's 2 cos 2t over sine 2t per 2 minus secant square t. Now, if we see, the question asks about cotangent t. That means we have to change the double angle in here into single angle. Now, what is the cos 2t? The cos 2t is 2, we can use 2 cos square t minus 1. Yeah, you can have this from the MF19. Per sin 2t, it's 2 sin t cos t. Per 2 minus secant square is the 1 over cos square t. Okay, yeah, we try to simplify, yeah. We can simplify 2 and 2, we cross out. And then, okay, let's rewrite first. Cos square t minus 1 over sin t cos t. We can move the denominator here. 2 minus 1 over cos square t. Okay, 2 cos square t minus 1 over sin t cos t. And then we can make the denominator the same here. Become 2 cos square t minus 1 over cos square t. Oh, we can cancel this. And then we have 1 over, oh, we can cancel also the cos here, becomes sin t over cos t. And it will become cos t over sin t, which is cotangent t. So it's proven. That's for number 1. Number 2. Find the exact value of integral x secant square x dx. This is integration by parts, yeah? So according to the rule LIATE, we have x as a and secant as t, because a comes first, so we can let u, yeah, x for u, and dv is secant square x dx. So du is dx, and v is integral secant square is tangent x. Nah, we can put into the formula. So this is equals to uv minus integral v du. So uv minus integral v du. So it's become x tangent x minus integral tangent x dx. Now, what is integral tangent x dx? Integral tangent x dx in here. If you see from MF19, you cannot find integral tangent x dx in the MF19. That's why we have to integrate it by ourselves. Now we know that tangent is sine x over cos x. So we put sine x cos minus 1x dx. We can use substitution. U is cos x and du is negative sin x dx. So this is equals to integral, I rewrite, yeah, cos minus x minus 1x sin x dx. Now, if you notice, this is the same, except for the negative number. Now, so we can put integral u minus 1 negative du. Yeah, we can change the sin x dx into negative du. And equals to minus integral 1 over u du, which is, what is this? Minus ln u. So it's minus ln cos x equals to ln 1 over cos, yeah? Ln 1 over cos equals to ln secant x. So now we already have the integral tangent. So we will have x tangent x minus ln secant x. Put the boundaries 0 and 1 over 4 pi. So this is equals to, replace the 1 over 4 pi, tangent 1 over 4 pi minus 0 minus the second term, ln secant 1 over 4 pi minus ln secant 0. Yeah. And then we calculate. What is tangent 1 over 4 pi is equals to 1. So 1 over 4 pi minus 0 minus ln 1 over 1 ln secant 1 over 4 pi is, okay, put the bracket, ln secant 1 over 4 pi is cos 1 over 4 pi, yeah, 1 over cos 1 over 4 pi. So this is root 2, yeah, minus ln secant 0 ln 1. equals to 1 over 4 pi minus ln root 2. Yeah, ln 1 is equals to 0. So plus 0. So 1 over 4 pi minus half ln 2. So this is the answer. Number 3. Express 4 cos x minus sin x in the form of r cos x plus alpha. Set the exact value of r and give alpha correct to 2 decimal places. So using the formula for r equals to square root of, this is a, this is b, so 4 square plus 1 square equals to root of 17. And for alpha, we can use tangent inverse 1 over 4. Yeah, equals to, we have to answer this in degree. Yeah, since the result will be in degree, so the answer should be in degree. Yeah, so the answer is equals to 14.04 degree. That's for the first one. So it's equals to 4 cos x minus sin x equals to root of 17 cos x plus 14.04 degree. B. Chance, solve the equation for cos 2x minus sin 2x equals to 3. Now, if we compare to the answer from A, the difference is between x and 2x. Yeah, the difference is between x and 2x. Now, that means this form is also the same as the previous form, which is root of 17 cos of 2x plus 14.04. Yeah, we only change the x into 2x, and this equals to 3. So that means cos 2x plus 14.04 equals to 3 over root 17. So 2x plus 14.04 is equals to cos inverse of 3 divided by root 17. So 2x plus 2x equals to 43.31 minus 14.04 equals to 29.27. So x equals to 14.64 degree. So this is the answer. Now, as we remember, the cos positive is in the first quadrant and fourth quadrant. Now, our answer in here is in first quadrant. This is first quadrant. Now, so what is the fourth quadrant, the second answer? The fourth quadrant is when x plus 14.04 equals to 360 minus 43.31. So what is this? 2x equals to 360 minus 43.31 minus 40.04. So 302.65. So x equals to 151.33 degree. So this is the answer for number 3B. There are two answers for this, yeah, two answers, because the cos positive are in the first and the fourth quadrant. Therefore, we have to find the angle in each quadrant. Continue to number 4. The equation of a curve is y equals to sine x sine 2x. The curve has a stationary point in interval 0 x until half pi. Find the x coordinate of this point, giving your answer correctly significant figures. Stationary point. So we have to find the dy dx equals to 0. So y equals to sine x sine 2x. The derivative is, we have to use the product rule in here, yeah? This is u and this is v. The formula is u prime v plus uv prime. U prime, derivative of u. So u is sine x and u prime is cos x. V is sine 2x and v prime is 2 cos 2x. U prime v is cos x sine 2x plus uv prime sine x times 2 cos 2x. This is equal to 0. Now, how do we solve this then? So this is 0. Okay, just rewrite the expression first. Plus 2 sine x cos 2x. Now, we have sine x, cos x, sine 2x, and cos 2x. So first, we have to change the double angle into the single angle. Yeah, we can change the sine 2x become 2 sine x cos x, CMF19 again, plus 2 sine x, and then I want to make cos 2x as 2 cos square x minus 1. Yeah, and then I simplify 2 sine x cos square x plus 4 sine x cos square x minus 2 sine x. So this is equals to 6 sine x cos square x minus 2 sine x. And we can simplify, factorize 2 sine x, 3 cos square x minus 1. So that means the zero maker are sine x equals to 0 and x equals to, this is radian, yeah, 0 and pi and 2 pi. But the x is between 0 until half pi, so we can ignore this. Yeah, we can reject this. And the second one, 3 cos square x minus 1 equals to 0. So cos square x equals to 1 over 3. That means cos x will be plus minus 1 over 3 and then square root. Now, again, x is between 0 until half pi. That means in the first quadrant. Cos in the first quadrant should be positive. So we only use the positive root of 1 over 3. So this is equals to 1 over 3 square root 3. And the value of cos is, we just use cos inverse. We just use cos inverse to find the x value. So 1 over 3, 0.955 radian. That's it. This is the answer. Number 5. The parametric equation of a curve are x 1 over cos t, y equals to ln tangent t, where t between 0 until half pi. Show that dy dt dx is cos t over sin square t. Okay, for the first one, again we can put in the formula. Dy dx is dy dt d over dx dt. Now, dx dt is, this is cos minus 1 t. So negative 1 cos minus 2 t times negative sin t equals to cos minus 2t sin t. Dy dt is 1 over tangent t times derivative tangent is secant square t. So put in the formula, this becomes secant square t over tangent t per sin t over cos square t. Now, we can do this. Secant is 1 over cos square t. Tangent is sin t over cos t. Cancel the cos over. We can put the denominator up, yeah, by cross cos square t over sin t. So this is equals to 1 over cos t sin t times cos square t sin t. So we cross again the cos. So it's become cos t over sin square t. Okay, proven. B. Find the equation of the tangent to the curve at point where at y equals to 0. Now, to make the equation of the tangent y equals to mx plus c. That means we need the gradient and we need the coordinates. The gradient can be taken from the first derivative, but we need to find the parameter first. Yeah, so given that y equals to 0, so when y equals to 0, that means ln tangent t equals to 0. That means tangent t equals to 1, t equals to pi over 4. Now, when t equals to pi over 4, that means the gradient is cos pi over 4 divided by sine square pi over 4. And this is equals to square root 2. Now, what is the x? X is 1 over cos pi over 4. So it's also square root 2. So that means we can find C, square root 2x plus C. So we put y is 0, square root 2, square root 2 plus C. So that means C equals to -2. Therefore, the equation of the tangent is y equals to square root 2x minus 2. Next, the curve y, e minus 4x tangent x, has two stationary points in the interval x between 0 until half pi. Obtain an expression for dy dt at dx and show it can be written in the form where a and b are constant. Okay, so to derive this, we will use the product rule. Yeah, this is u and this is v. U is e minus 4x. U prime is -4 e minus 4x. V is tangent x. V prime is secant square x. So dy dx is equals to u prime v plus u v prime. U prime -4 e minus 4x tangent x minus plus u prime v e minus u prime uv prime e minus 4x secant square x. So we can factorize -4 tangent x plus secant square x. Now, if we see the form, it contains sine 2x. So that means we have to change the tangent into sine. So this is -4 sine x over cos x plus 1 over cos square x equals to e minus 4x. We make the denominator the same here. So -4 sine x cos x over cos square x plus 1 over cos square x. Now, now we can see that this can be written in the form of -2 times 2 sine x cos x. Per cos square x plus 1 equals to e minus 4x -2 sine 2x plus 1, and then 1 over cos square become secant square x. So this is the same with the form in the equation. Secant square x 1 minus 2 sine 2x e minus 4x. Okay, B. Hence, find the exact coordinates of the two stationary points. So that means we make the dy dx equals to 0. So e minus 4x, 1 minus 2 sine 2x, secant square x equals to 0. Okay, which function can make it 0? E is never 0. Secant is also never 0 because it's 1 over cos. 1 over cos, it cannot be 0, right? So the only one that can make 0 is 1 minus 2 sine 2x equals to 0. So 2 sine 2x equals to 1. Sine 2x equals to 1 over 2. So that means the 2x is sine inverse 1 over 2, which is pi over 6. This is in the first quadrant, or 2x in the second quadrant is 5 over 6 pi. Yeah, remember that sign positive are in the first quadrant and second quadrant. So from here, we can have x equals to pi over 12, or x equals to 5 over 12 pi. Yeah, so both of them are in the interval 0 until half pi. Okay, number 7. Let I equals to integral 3, 0, 27 over 9 plus x squared dx. Using the substitution, show that I equals to that. Okay, yeah. In here, using the substitution of x equals to 3 tangent theta. So that means I is integral 27 over 9 plus change x into 3 tangent theta. 3 tangent theta square, and then square again, dx. So what can we have? Integral 27, 9 plus 9 tangent theta, tangent square theta, square, dx. Now, we cannot have dx and theta in the same time. So we have to find the conversion dx to d theta. Now, from x equals to 3 tangent theta, we can find dx, yeah, the derivative of x is 3 secant square theta d theta. So we can substitute the dx. So this is 27. This is going to be simplified 9 plus, 9, 1 plus tangent square theta square. Dx we substitute with 3 secant square theta d theta. Okay, integral. So we have 27 times 3 secant square theta d theta over 9 square is 81. 1 plus tangent square, yeah. Using identity, it will become secant square theta square. Yeah, change the 1 plus tangent square theta into secant square theta. That means this is equals to 27, 3 equals to 81. So we can cross the 81. So this is secant square theta over secant square theta, secant square theta d theta. So cross. So it's equals to 1 over secant is cos square theta d theta. Now, how about the border? The border of the boundaries, yeah? Now, 0 and 3 are the boundaries for x. Because now we are using theta, so we have to convert the x from 0 into theta. Now, using this formula, when x equals 0, what is the theta? The theta is 0 because tangent 0 is 0. Tangent 0 is equals to 0. When x equals to 3, that means 3 tangent theta equals to 3. So tangent theta equals to 1. Theta is pi over 4. So that means the boundaries change from 0 until 3 into 0 until 1 over 4. So 0 and 1 over 4 pi. Yeah, this is the first one. And B, find the exact value of I. Now we integrate this. Integral cos square theta. Now we cannot integral cos square theta directly. We need the help of cos 2 theta. We know that cos 2 theta equals to 2 cos square theta minus 1. So cos square theta means cos 2 theta plus 1 divided by 2. So we can rewrite this I equals to integral cos 2 theta plus 1 divided by 2 d theta. So integral, I put the half outside, cos 2 theta plus 1 d theta. So half integral cos 2 theta is half sine 2 theta plus theta. But the boundary is 1 or 0 until 1 over 4 pi. So we can put the into the formula. 1 over 2 sine 1 over 2 pi minus 1 over 2 sine 0. Okay, I put the bracket plus 1 over 4 pi minus 0 equals to 1 over 2 sine 1 over 2 pi is 1, yeah? So half minus 0 plus 1 over 4 pi equals to 1 over 4 plus 1 over 8 pi. Yeah, this is number 7. Number 8. Using the expansion of sine 3x plus 2x and sine 3x minus 2x, show that. Okay, yeah. So first we have to expand this. Sine 3x plus 2x is sine 3x cos 2x plus cos 3x sine 2x. And then for sine 3x minus 2x, this is become sine 3x cos 2x minus cos 3x sine 2x. Now, if we put into the formula, so half of sine 5x, which is the first one, sine 3x cos 2x plus cos 3x sine 2x plus sine x. Sine x is the second one, sine 3x cos 2x minus cos 3x sine 2x. So we can cancel cos 3x sine 2x. So it's become half times 2 sine 3x cos 2x equals to sine 3x cos 2x. Proven, ya? B. Hence, show that so integral of sine 3x cos 2x is integral of half sine 5x plus sine x dx. Yeah, we can change the form this using our answer in number 8a. So I can put the half out, sine 5x plus sine x dx. So I have half sine 5x is negative 1 over 5 cos 5x minus cos x. The boundary is 0, 1 over 4 pi. Okay, so 1 over 2. Okay, I put the bracket here. Okay, I put here negative 1 over 5 cos 5 over 4 pi minus cos 0 minus cos 1 over 4 pi minus cos 0. Half negative 1 over 5 cos 5 over 4 pi is equals to negative cos 1 over 4 pi. Ya kan? Since 5 over 4 pi is in the third quadrant, so it's negative. Yeah, negative cos 1 over 4 pi. Minus 1 minus cos 1 over 4 pi minus 1. Okay, 1 over 2. Okay, calculate 1 by 1. Negative 1 over 5 minus 1 over 2 square root 2 minus 1 minus square root half square root of 2 minus 1. Okay, half 1 over 10 square root 2 plus 1 over 5 minus square root 2 half square root 2 plus 1. So what is this? I can combine the square root 2 become 1 over 10 square root 2 minus 5 over 10 square root 2 plus 1 over 5 plus 5 over 5. So this is minus 4 over 2 over 10 square root 2 plus 6 over 5. So if I can multiply it by half, it's become negative 2 over 10 square root 2 plus 3 over 5. So I put the 5 out, yeah, 1 over 5 out, and then I can have 3 minus square root 2. Proven.